Alright, so I'm going to try and explain this as quickly as I can, right? So here's a question that is asking us to find all the points of the horizontal and the vertical tangents if x is this and y is that, right? These are parametric equations, because it's a function defined by this variable, another function defined by the very same variable. So your parameter is theta there. So now the concept is like this, right? The concept is that if you find the derivative as a over b, then your horizontal and vertical asymptotes, you're going to find them on two places. Remember that parametric equations could be equations that are like this, right? They can actually form something like this. Usually I like to say to my students, imagine that an insect is going around, and then it's traveling like this and then like that. So this can be your parametric equation. Now in terms of asymptotes, right, you can have a vertical asymptote, and then in terms of tangency, you can have a vertical tangent and a what, and a horizontal tangent. So the main idea when a question says like this, find all points, the main idea is to find those 2 points in which you can draw a vertical and a horizontal asymptote. And they could be many. There could be another one here, and then there could be another one there. So the main idea is to say, remember that the gradient of a tangent is if the derivative is equal to 0, if the derivative is equal to 0, remember that you have a horizontal tangent. You have a what? You have a horizontal tangent. Remember when we had a parabola, when we were saying the maximum, it means the tangents were always horizontal. Even if when you had equations like this, the tangents were horizontal, because we used to say let the derivative be equal to what? 0. Now the tangent will be vertical. The tangent can be vertical like this if the gradient or your derivative is undefined. Remember that a vertical line, the gradient of a vertical line is undefined. This means that you should have a over 0. Okay, so meaning that we are going to have horizontal tangents when our first part is equal to 0. So horizontal tangent exists when the first part will be equal to 0, and then our vertical tangent will exist. Let me write it here. The vertical tangent will exist when the bottom part is equal to 0. That is the main idea. So that is what we're going to try and use in order to solve this problem, right? So the first thing you're going to do, since this is a parametric equation, definitely you need to find the derivative. Okay, you need to find dy over dx. So what you do first, you say remember dy over dx would be equal to dy over d theta divided by dx over d theta. Then therefore you can then say right, that therefore you can then say what?